So, as you noticed, this talk will be in English. My colleague, with whom I should have done this presentation, Mete, is not there with us today, unfortunately. So, we'll stick to English, also because we've got the subtitles and everything, I guess. Yeah, in English. So, let's do it in English, right? So, I had a quick look on the agenda, and I noticed there was a DALL-E presentation in another room. So, don't worry, there will be like 4 or 5 pictures generated with DALL-E. So like those 2 ones there. So we're here to speak about choreography and orchestration in microservices. And so I've done that talk a few times already, but this is a new version of this talk because I'd like to keep at the end a bit of time to talk about patterns, best practices around orchestration in particular. So yeah, I'm Guillaume Laforge. I'm a developer advocate for Google Cloud. Well, you can follow me if you want. Nothing mandatory. So choreography versus orchestration. That's 2 ways to orchestrate microservices. Because that's the question you may have. Like, how do you actually organize a group of microservices to cooperate together towards a certain goal, like achieving some kind of business transaction, business workflow, business process, etc. So there are different approaches to this, and we'll have a look at a few of them, and we'll see what are the pros and cons. And I'll dive a little bit deeper on workflows, the orchestration pattern, the orchestration approach. So let's imagine one approach where we have some kind of e-commerce website. So you would have, so here I'm showing some icons from Google Cloud, but it can be any technology on any cloud. It doesn't matter if it's Google or not. It's not a product pitch here. So you've got let's say, some kind of boutique, some kind of shop, and then you've got a front end. I think I can show you that on screen. So you've got a front end there, web front end, that's going to send a request to a service that is going to be our payment processor. The payment processor, once the credit card is authorized, charged, etc., it forwards the request to a shipper, and the shipper is going to prepare the parcel and send that parcel to the person who bought this thing. And then you may have another service at the end which notifies the user, okay, you're going to receive the parcel on this particular day. So here, with this approach, you've got the front end that makes a direct call to the payment processor, then the payment processor, when it's done, does direct call to the shipper, etc. So it's a chain of direct calls. But, so there are pros and cons with this approach. In terms of pros, it's easy to implement. It's just a, a synchronous service call. There are many ways to do that. It's fairly easy. But on the other hand, there are probably more downsides to this approach. So first of all, there's a really tight coupling happening there because, this particular service has to know about this other particular service, etc. They will really know them, each other probably a little bit too closely, too tightly. Each service can also be a single point of failure, because if at some point there's a failure in that chain of service invocation, then what happens? The whole transaction, fails, and it's not necessarily easy to recover from that, or you have to, transfer the errors back to the front end somehow. Each service also needs its own error, retry, timeout logic. So it's at the point where you make the synchronous call that you have to be mindful of how you want to handle errors, retries, and so on. And also, especially because of that chain, and we'll come back to a pattern at the end of the talk, how do you ensure the whole transaction is successful? And if not, how do you backtrack and potentially doing compensation steps, etc. So that's what the saga pattern is about, to actually come back to a sane state. Like, you've charged someone, but you've not sent the parcel, or, well, I think the customer won't be happy. So another approach, which is the choreography approach, which is the event-oriented approach. So indirectly via events. So this time, so you still have the same services, but they don't really know about each other. What they are going to do, they're just going to exchange messages on some kind of message broker. So it could be Kafka, it could be Pulsar, it could be PubSub on Google Cloud, it could be anything, basically. So they just exchange messages. So they send some messages. OK, the front end, I got a request from a customer to buy something. I'm going to send that message to the message broker. And someone will pick up that message. So who will pick up that message? Well, the payment processor knows that, oh, someone wants to buy something, so I'm going to pick up that message. If it's successful, I'm going to send a message saying it's successful. Then the shipper can pick up this new message, etc. But if the payment fails, perhaps it's going to send another kind of message, and another service may be able to pick up that error case and do something about it. So this is great. Well, I'm going to mention the pros and cons in the next slide. So there are many tools to do that kind of stuff on Google Cloud, like PubSub or Event Arc or SQS, SNS on AWS, etc. I won't read them all. RabbitMQ. Many message brokers exist, right? So depending on your architecture, you might prefer one or the other. So let's have a look at the pros and cons as well. So here, services are loosely coupled, so they don't really know about each other. So they're not, I mean, they can be developed and deployed independently from each other without ensuring that, oh yeah, I changed the way, like the contract of the direct invocation would be, I would have to change both services, etc. Here, well, perhaps you may change the payload exchange in the messages, of course, but at least it's much more loosely coupled than in the direct invocation case. Services can be changed, scaled, deployed independently, in the sense that, okay, I've got a new version of that particular service, I'm going to deploy that new version, and I don't have to deploy all the other services at the same time. Or I could also handle situations where I have different versions of the services that handle different message formats, potentially. But it's much more, well, it's nicer to work in that situation where services can be deployed and developed independently, and teams can focus on their own thing, etc. There's no single point of failure, so if at some point, let's say the shipper goes down, what's happening? Well, he won't be able to pick up the message that stay in the queue for shipping the parcel, but at some point, you know, it'll be back, and it'll be able to pick up the messages that were left in the queue waiting for it to return. So it's also pretty smooth. Events are useful or easy to extend. So yeah, it's easy to extend the system with new events or existing events. So for example, I want to add a new service, and it needs to consume the same event as other services are also already subscribed to. Then, you know, you just add the service into the loop, and it will be able to look at the topic and see, oh, yeah, I'm also interested in that one, so I'll pick it up as well. Similarly, if you have new processes, maybe they will require new kind of events, new kind of messages, then you can just add and create new messages and get them through the message broker. That's also a great way to extend the system fairly easily. In terms of cons, so usually, in my experience, it's more difficult to monitor because it's not like, you know, you're not really able to put a debugger at some point and say, okay, I want to see who receives what and calls who, etc. So it's more complicated to actually monitor what's going on, and especially when you've got so I had an application that was like this, where there were several persons going into the system, so you would have messages for different orders. And then when you try to look like at the logs in your logging system or whatever it is, then you're not sure, okay, oh yeah, I saw the message I was looking for. Ah, no, that was for actually another customer. So, well, it's a little bit more complicated to actually understand what happened, especially when something fails. You know, you'd have to use correlation IDs, really just fetch the logging messages and the messages that are in the queue that correspond to that correlation ID. So it's a little bit more complicated than just putting a breakpoint somewhere in some service. Errors, retries, timeouts are also hard. Well, it depends as well, also on the underlying message broker technology that you are using potentially, because you can also configure like your queues, your topics, to do different things depending on the messages potentially. But yeah, you don't have, or something that happens sometimes is that a service is used across several different, distinct transactions, and perhaps you don't have the same requirements in terms of error handling. So for example, in one particular scenario, you should really try several times till it works. But in another cases, well, if it doesn't work, it's okay to wait longer or something like this. So you don't necessarily have the fine-grained capability that you also had in the direct call, because the one calling the other was in control of how that call was being made. So that was probably a pro of the other more direct approach. But here, yeah, it's not as fine-grained as it could be, potentially. And another downside is that the business flow is not captured in the sense that when you have the direct approach, you just follow the code, like, okay, this one is calling this one is calling this other one. But here, you're just sending messages through a broker. So the actual behavior, like the business behavior, is not really, it's an emergent aspect, an emergent characteristic of the flow of messages, but it's not written clearly anywhere, like in a file, in a source file, or some configuration file. It's not written explicitly, okay, this service needs to call this other service, even if indirectly via a message broker. So it's not clear what's going on. So especially, let's say you've got a newcomer that joins your team, and you want that person to be to understand what's going on in your application. Then, well, just follow the flow of messages, and you'll figure it out. Well, that doesn't quite work that way. So unless you document properly the way messages are exchanged, it's hard to grasp what's going on in an existing system or in a legacy system. And same thing with the direct synchronous approach. Also, how do you ensure that the whole transaction or business process is successful? Perhaps you'd have to monitor particular messages, like the first message that was sent that triggers that transaction or workflow, and like the final message that you expect. Then you know that, well, if you didn't receive the final message, then that means it failed, or perhaps it takes longer. Hard to know the difference. So then imagine a more, so this was a pretty, let's say, serial approach where one was calling the other, whether it was direct or indirect via messages. But in a more complicated scenario, it's even harder to fully understand what's going on. So imagine something like you have to check, so it's written pretty small, but I'll go through the flowchart with you. So let's say you're going to check the inventory, if it's available or not. So if it's out of stock, then you might call a supplier to replenish the stock. But if it's in stock, then that's fine. You're going to prepare the order. You may have to update the inventory to say, OK, now there's one item less, notify the customer, and perhaps you may have some extra conditions, like if it's a big sale, a big order, perhaps I want to involve the sales team to add them in the loop. So here, simple messages. In an event-driven approach, it might also be complicated to put in place because, I mean, it's not like you can't really put conditions on messages. So you'd have to pick certain messages and analyze them and see, okay, should I launch different kind of messages for the different cases? Well, it's more complicated as soon as the business process is more complicated and has branches and loops and things like that. So it's even harder to monitor. Another approach, which if you look at the diagram, it may look a bit more like the choreography approach. Here, this time, we have an orchestrator. So it's a project, a service, some kind of service, that is going to be responsible for tracking the state of the transaction. So you still have the front end on the left that is going to send the order request, send that to the orchestrator, and it's going to trigger the execution of the workflow. And that's the orchestrator that knows who needs to be called, when, at one point in the process, or who is also able to know, okay, this order is less than 1K euros, so it's okay. If it's more than 1K, perhaps I'll involve the sales team. So you can also put some logic there to say, okay, the path in my business transaction might be different. So it's a central, central tool that will allow you to properly track the actual state of your business transaction or flow. So for that, there are also many products. So there are more classical products like Camel or Camunda, who've been there for a long time. Among the cloud providers, I'll show you workflows, Google Cloud Workflows in action. But at AWS, you've got step functions, you've got logic apps on Azure. So it's a pretty common thing nowadays. So pros and cons again. So business flow captured centrally and source control and version. So I'll show you the Google Cloud Workflows product in a minute. You've got a YAML file that really describes the process. So, okay, I need to call this, I need to call that. If this order is more than this amount, then this, etc. So you can have not logic, but at least, well, let's call it some light kind of logic with loops, with conditionals and such, to define a tree or some kind of graph representing your workflow. And since you have a file, you can also version that file and put it in Git, in your source repository. And you can also share that with among your developers, and that can also help to document the actual flow and interactions between the various microservices of your application and of your infrastructure. So it's a great way to understand what's going on in your system of microservices. Each step can be monitored, so you can see, okay, there are 10 executions of that transaction at the moment for 10 customers. I know that this one is at step order processing. I know that this one is at step shipment, etc. What's interesting as well for retries, timeouts, etc., is that in the workflow definition itself, you can say, okay, I need to call the shipper service, but then I want to retry a certain amount of time over a certain course of time, or I want to handle errors that way, or I want to add an exponential backoff, so I want to try in 1 second, then in 2, in 4, in 8, 16, etc. So you can define that logic centrally in that kind of configuration file, which means also that if you call the same service different times, you could have different parameters for error handling as well. The services are still independent. They're still, their own islands. In terms of cons, so it's, of course, a new tool to get to learn and to use. It can be a single point of failure, of course, if your orchestrator crashes or something, it stops running, then all the transaction won't be able to proceed. So that can be seen as a single point of failure. Although, I mean, if you're running in some kind of cloud, whether it's step functions on AWS, whether it's Google Cloud Workflows, it's supposed to be a service that has some high level of SLA, so 99.99 availability or something like this. So usually, it may fail, but if it fails, it means that there may be other things going on in the internet or something. So it can fail, but shouldn't fail too often, compared to like running your own orchestrator on your own. Sometimes, well, that was the feeling. So the application I built, so in a previous version of this presentation, I was showing a concrete example of a small application that I had built. I had built that initially with an event-driven approach, and then I rewrote it using an orchestrator. But one thing I noticed was that in the pros of the event-driven approach, I was saying that it's easy to add a new kind of event, or it's easy to subscribe to an existing event if you want to extend your system. In that case, with a YAML file, JSON file, whatever the format, defines your workflow in a certain way. Like how do you add a new event into that picture? So you have to test the whole business process all over again, redeploy it, and check that it still works the way it was working before. I mean, it's not that you don't have to test it in an event-driven approach, but usually you usually focus more on your service than the overall behavior of the whole system. So you may lose, well, you can argue about it or not, some eventing flexibility that you had with the event-driven approach. And still, like when something fails in that business process, in that workflow, how do you compensate to get back to a good state? And again, that's going to be the saga pattern we'll mention in a little moment. So when to use choreography or orchestration? There are pros and cons to both approaches. So the usual answer, you know, in IT is it depends, right? So we'll revisit that question later on. And it doesn't mean that one is really better than the other. And on the contrary, I would say also, I forget if I have a slide. No, perhaps I have it later on. The thing is that sometimes you can actually combine both approaches. So for example, for like in domain-driven design language, you would speak about bounded context. So for a certain context of execution, maybe using an orchestrator is great. But for the overall system, you may have something that is event-driven, and that is going to trigger the orchestration of some other processes. So that's what I've seen from some bigger system, like some at our customers. A mix of orchestration and choreography. So they are not, it's not one or the other, it's not black or white, you can combine both. So let's zoom a little bit on orchestration. So I want to start first mentioning that the concept of workflow is not new, so there are all sorts of existing solutions like BPMN, notation, BPL, etc. So there were older things that existed. There are also new revision of the concept, let's say. So for example, as part of the CNCF Foundation, there's a new currently it's still incubating, but there's a new project called Serverless Workflow, which tries to define a vendor-neutral approach to defining workflow definitions and interactions, etc. So there's the specification of the DSL to describe your workflow, SDKs to interact with such products and available in different languages, so you can integrate it in any architecture, regardless of the technology you use. Runtimes that would implement that specification, some tools to help designing those workflows, and it's also using some existing specifications like OpenAPI to describe the contract that the different microservices expose, and also cloud events. So when you don't call the service directly, but you exchange events. So cloud events is also another specification that we also use, for example, on Google Cloud for the events that cloud functions can get. So if you do functions as a service in Google Cloud, we also use the cloud events format and specification to describe the events we receive. So it becomes becoming more widespread, I would say. But the thing, so it's still pretty new, still incubating, and sometimes, so a spec can cover a certain ground, a certain number of features, and a product, a different set of features. So there may be an overlap. So if you're using the spec, so that's why I've put this little Venn diagram. So if you're in the intersection of the features of both product and spec, that's fine. But if you just stay within the spec, perhaps you won't be able to use advanced aspects of your product, or on the other hand, perhaps you use a product that doesn't cover the whole spec. So you have to check what you can really use for that. But it's something I want to, so it's something also at Google Cloud that we keep an eye on, because perhaps at some point we may be able to support that particular format instead of our own proprietary, YAML format. And I'll zoom in on Google Cloud Workflows. This is the one that I'm going to show you concretely at the end when I'll be talking about patterns and best practices. So Google Cloud Workflows is about orchestrating APIs, services, microservices, etc. So you can, from a workflow definition and execution, you can call anything that would be hosted on Google Cloud. So for example, if you deploy containers on Cloud Run, functions on Cloud Functions, etc., you can call easily those APIs and services. You can also use and call all the other services offered or APIs offered by Google, like, I don't know, the translation API. I have an example later on with that. You can call, I don't know, yeah, some machine learning API or others. But you can also, of course, call external APIs and services, so SaaS kind of products. So in some of my own projects, I was using like the SendGrid service to send emails. So it's fairly easy and trivial to do that. And I'll show you another DALL-E image. I love the images that are generated by this thing. It's pretty amazing. So the other talk might be more interesting and show more pictures, but you know, that's DALL-E at play here. Just to show you what the product looks like. So you have dashboard. You can see, you can have some metrics about what's going on. So in terms of monitoring, that's interesting. You can also have a look at the logs as well. You have the list of existing workflows that you have on your per project, on a per project basis. You have the definition, so that's where you're going to see how I define. So this is the source view. This is not the edit view, but that's the same. So you've got the YAML definition here, and you also have automatically the visualization with a little flow chart that represents how your workflow is going to work. You can see, so this screen looks a bit like the list of workflow, but this is the list of executions of workflow. So what's interesting is that, so these ones all succeeded and are all finished, but if they are running, you have a different little icon there. You can also see, okay, I'm at this particular step of my workflow, duration, time, and so on. You are also able to call the workflow directly from the interface and have a look at the results. And for example, okay, this one succeeded, input, output, and the logs associated with that particular execution. So you can really understand on a per execution basis what happened in your workflow. Okay, so for the example I'm going to show you later on, I want to introduce you to the actual syntax of workflows. So again, DALL-E image. I really love it. So back to like a similar example we had in the beginning. So you've got different steps in your business process. So I still have the payment processor, the shipper, the notifier. So in YAML, you would have like each of these lines highlighted are steps with the names. And inside those names, I'm going to call those services. So it's really a sequence of steps. Here, they're going to be called sequentially. Then you can also, so let's say the process payment is going to return, so taking some input, but also return some output. And I can access the result of previous step and service calls. So for example, I can say, okay, I want the body of that call, so it's an HTTP call, so I want the body, the actual payload of that call, of the result. And I want to get the address because I'm shipping product, so I need the address to send to the customer. So you can pass in and out the right information that each service needs. The way you're going to call the services, here you're going to say, okay, I want to make an HTTP post to my particular service. Here's the URL of my service. Here's the input, here's the output. Of course, you want to secure things. So for example, if I use services that are hosted on Google Cloud Functions, Cloud Run, etc., I just have to do it in a declarative manner. So I want to say, okay, it's using OpenID Connect to authenticate to those services. And it's really just declarative. I just have to say auth type OIDC, and it figures out how to connect and interact with that particular service. So there's OIDC, there's OAuth2 as well. So for example, for the like the machine learning API I would want to use, I may be using the OAuth2 authentication. Then, of course, if you've got some other approaches for authentication, you may be able so to pass the body, but also headers, etc., to pass a bearer token or that kind of stuff. You can also do that manually. But at least for the ones that are running within Google Cloud, it's just declarative, so that's pretty cool. If you know that certain things take a bit of time, there are some built-in functions like a sleep to say, okay, I want to sleep for 60 seconds because I know some stuff is going to take some time. So you can introduce that. At each step or after each key step of your workflow, you may say, okay, I want to log some information because I want to know, okay, I progressed there. Here's the ongoing step, or here's the ongoing status of something. So you can log, and it appears in the logs in the console. But there are many such built-in functions to deal with encoding, text encoding, also things like the error handling, etc., or how you want to encode, decode stuff with JSON. The other thing, yeah, I don't have an example. Oh, I might be showing an example of this with callbacks, which is a way to pause the execution of a workflow to say, okay, I need some extra information, extra data, perhaps like a human intervention, potentially, a human that is going to validate something. So you say, okay, I want to pause for a second there, and I expose a new URL endpoint, and someone needs to call back that endpoint to say, okay, you can proceed further, I approve, I reject the transaction, or something like this. Callbacks are pretty useful. Then, in terms of error handlings, so it's a bit like, you know, in Java, JavaScript, etc. It's a kind of try, except block, where you say, okay, something failed here, I didn't get a 200 status code. So depending on the error that is received, perhaps I'm going to go into different directions in my workflow. So perhaps some errors are unrecoverable, but some may be recoverable. So here I also introduced how if-else look like. So it's a switch condition, basically. And if really, I mean, there's no way to recover, maybe raising the error again, and the workflow execution will just fail and will show us red in the console. For retries and backoff, so here I want to say, okay, for the payment processor, I want to try, I know it fails once in a while, so I'm ready to try like 5 times. Perhaps I'm going to do a little exponential backoff and say, okay, I want to try again in 1 second, then in 2 seconds, because there's a multiplier of 2 seconds, 4 seconds, 16 seconds, 32 seconds. And because the max is 60, it's not going to go over 32, actually. You can also, parts that are reusable, you can also define functions, or we call them sub-workflow, which also take parameters. Well, I think I may be able to keep some of this because it's the specifics of the product. Like, for example, we've got connectors that simplify the execution of, for example, here, BigQuery, that's our data lake kind of product. And if you want to wait for long-running tasks or APIs, it's going to wait without you having to write a loop, etc. Well, there are some advantages. I'll skip that. And there are many connectors with existing services or products. So for example, there's my colleague Mete actually wrote some cool examples using Google Sheets and Google Forms, so that, for example, it's a business transaction, and perhaps it's going to show up in a Google Sheet, and then you can say, okay, I validate from the Google Sheet, and then it calls back the workflow to continue its execution. So you can have some interesting scenarios using Office Suite kind of products. That's pretty cool. What else? Yeah, a few more, like iterations. If you want to do iterations, for example, when I do some queries on BigQuery, I want to query different tables of data. So I can have a for loop. So with the index, in which table. So it's really just, again, pretty declarative. And if I want to do it in a parallel fashion, I can just say, OK, actually, you're going to run that for loop in a parallel way. And here are the variables that the different threads may be accessing. So you have there's going to be only one particular step that's going to be allowed to write to that particular variable. So you don't have to focus on you know, semaphores and whatnot. Parallel steps, also parallel branches. So parallel iterations, that's iterating and doing the same thing on the data. Here it's parallel branches, so branches that do potentially completely different things. So it's pretty similar to for loops. Then when you want to deploy your workflow, either you use the console I showed earlier, or you can also use the G-Cloud SDK to deploy stuff from the command line or from your CI/CD, etc. And there are also APIs to do that programmatically. Okay, so now perhaps the most interesting part. So this is, I'm illustrating this again with cloud workflows, but I think it applies to all the orchestrator products. So it's not specific to Google. I want to highlight this because it's not just about one particular product, but it's patterns and best practices that you can find across that category of services and products. So back to the different approaches that we mentioned in introductions. So there are different ways to handle this. So you've got the direct call approach, which allows you to have a pretty simple architecture, only a few services that don't change that often. Perhaps direct calls is just fine. But as you're going to have a bigger and more complicated system, then you may be, it will be better to use either an event-driven approach or an orchestrated approach. So with an event-driven architecture, as we mentioned, services are not closely related. They can live pretty independently. There's not necessarily a notion of doing, well, everything kind of runs in parallel. As soon as you receive a message, you're going to execute. So it's not like serially in your code, although in your code you could also do things in parallel, of course. There's not necessarily an order guarantee. And as I said when I was mentioning domain-driven design, services can exist in different bounded contexts and be used in different scenarios and transactions. And with the central orchestrators, perhaps service will be a bit more closely related, or at least their contract is more strictly specified because you're back to particular REST APIs, etc., or open API contracts. And usually you would also deploy and execute things in the same order. So it's not so much that order is guaranteed, but that the fact that in the workflow definition you do things sequentially, step by step, makes you more sure that things are really going to happen one after the other and not potentially in parallel. So for example, in the example application, but that I'm not showing, I had one particular event, two services were subscribing to the same event, and sometimes one of the services was finishing before the other service, and I had to account for this in another service that was happening after that, because the treatment was different if one was finishing before the other. So you have to be aware of, oh, it's event-driven, so I have to pay attention to who finishes before the other. And yeah, with the central orchestrator, what's great is that you can define the workflow, the process in a nice flowchart. Or usually, if you think of a particular business transaction and you think you're able to actually write a flowchart saying, okay, yeah, we're going to call this service, this other one, we're going to pass that data to this other service, and with that condition, perhaps I'm going to go in that branch, etc. If you can describe stuff in a flowchart, then maybe using an orchestrator is really the good approach. So let me highlight some things there. So here, I've got several examples, so I'll go quickly through each of them. So here I've got an image processing pipeline where there are new images that come in a bucket, and this is going to actually trigger. So there's another product that I didn't mention, which is called Event Arc, that reacts to events in your infrastructure, and that can invoke workflows. So my workflow is invoked as soon as there's a new file in a cloud storage bucket, and then I can get the service to call different services, for example, adding a watermark, resizing, adding labels to understand what's in the picture, potentially, or filter if it's something that shouldn't be shown publicly or something. So let me show you some of these examples. So with the event-driven approach, so this is here. I think I'm just going to show you the YAML definition. Is it readable, even in the back? Yeah? Okay. So let me show you. So for example, we have First, so here I've got I'm changing the URL on deployment, so that's where you see some tokens that need to be replaced. But basically, you're going to have a service that is going to filter and say, is this image safe to display publicly? Then, okay, I'm going to do the rest of my logic, and if not, I'm going to go in a different branch. And again, see that it's an authenticated service, but declaratively, I just say, okay, use OpenID Connect, and that's fine. So I've got some conditions there. So depending, okay, it's safe, then I go to the labeled service. Otherwise, I go elsewhere. But here, in this approach, although it might be a bit misleading, because here you have the impression that the services are running in parallel. But it's actually the workflow that calls this one after the other. So it's not parallel. So that's why if I come back here, there's a first step to label the pictures, to resize, and to do watermarks, and then return some results. Okay, so that's the event-driven event-driven orchestration, in the sense that an event triggered the whole business transaction with event arc, and then the orchestration kicks in and calls the different step. So it's already a mix of the two approaches. Another thing is that, so I told you about the saga pattern. When something fails, sometimes, oh yeah, something I didn't mention, like when you use a product like workflows, transaction can last for a year, a full year. So it's not the transaction that you can quickly commit and roll back, but it can be stuff that runs a long time. And in that case, so just like in the old days of banking, where you had compensation systems, so let's say this order service called the customer service to ask for a credit. Perhaps in one case, it's going to approve the order, so you're going to do the balance between the accounts, etc. Or it's going to reject the order, so you have to get back to the previous state. So in this case, well, not sure this one is super interesting to show, because there's basically just, well, there are different approaches in that particular example. Yeah, so let's see, perhaps just the last one, which shows the whole pattern. Because so in this particular example, so everything is on GitHub. As you see, there are links. When I'll publish the slides, you'll be able to have a closer look at those examples. But here, I'm handling the case where something fails, and then I'm coaching that situation, and then I'm going to apply compensation to reject the order and get back to the previous state. So that's the approach. And here it's a simple case, but you may have different stages, and you may have to reverse all the intermediary steps that you have in this process. For example, you want to, so if you charge someone's credit card, then you prepare the shipment, but then there's something else happening. So you have to cancel the shipment, but also charge back the credit card. So you may have different stages. Okay, so this is good to handle errors that may be happening in your workflow, in your business processes. So yeah, this one. So there are two examples there. I'm going to show you. So which one? I think I can show you. I think I've got the demo running somewhere for that one. Where is it? So callbacks. That the stuff where it involves. Yeah, I'm going to show you this one. Where it involves. So it's not a pure technical transaction in the sense that humans can also be involved in that loop. So for example, here I've got I'm going to call the machine learning service to do translation, to translate English into French. So I don't know, DevFest is the best conference, right? Do you agree? Yeah, good. So I'm going to call the machine learning API, and let's see what it's going to say. So it's calling, it is going to save the results. Takes a bit of time, what's going on? That's probably the demo effect. So do you think the machine learning service disagree with that statement? That's a shame. So let me just read. Oh, I reloaded. So let me do it. DevFest is the best conference. Let's try again. Translate. Okay, going on. What's going on? Come on. Firestore update. I can't write on Firestore. So I'm using, yeah, something I wanted to say. I'm using Firestore to save the actual state. So normally, what should happen when things work fine, and it was working fine yesterday? So here, you should get the actual translation, the first. It never took as much time. But it's still the best conference ever, right? So in that case, I get, so the actual, perhaps I could show you. Yeah, I don't have that much time, so I won't dive into more details. But here, I defined a callback endpoint to say, OK, I received the translation, but then I want you to validate, to agree or not with the translation. Machine translation, but I want a human being to double-check the actual translation. So there's a human, so the workflow is posed, and then the human has to click one of the buttons to validate or reject. So should I validate or reject? Validate. I'm going to click and say, oh, I'm resuming the execution of the workflow. So it continues with the information that it's been validated, and it can update the database with that information. So very quickly, if I show you, so that should be this example. Very quickly how it looks like. That should be here. So here, what we're doing, where is it? So translation, I call the translation API. I save it, and you're going to see. So here, I'm creating a callback endpoint. So it's a URL that someone will have to call to resume the execution of the workflow, and so I'm saving it into Firestore because I wanted to have the interaction on the using Firebase, etc. I'll spare the details. But then I await the callback. I'm now waiting, pausing the workflow to say, I want someone, a human, to validate or not the actual translation. And then it proceeds, it continues. So that's one pattern. And using Firestore as a kind of state handling database. Also, so it's a good thing to parallelize things when you can. For example, I was mentioning BigQuery earlier. BigQuery is great. You can go through tons and super heavy data sets like, for example, if you want to analyze the Wikipedia data set, perhaps like you want to find the most popular pages on Wikipedia on a particular month. Then if you're looking at 5 different months, each query will take 20 seconds. So 5 times 20, that's more than 1 minute. I didn't say I was good at math, right? So 5 times 20 seconds, OK, it's going to be 100 seconds. But instead, if you use parallel steps, you can say, OK, I want to run those queries in parallel. They are totally independent of each other. I'm going to run them in parallel, and instead, the 5 queries will return more or less in 20 seconds. So this one, it was really just like the example I showed about the syntax of parallel steps. So this is this one. And here I'm just saying, OK, these so the queries with a big query are going to run in parallel. And here are the shared variables in which you'll put and save the results. OK, one more. So another pattern, well, I won't necessarily show this one. I don't have much time left. So this is a serverless product that is fully managed by Google, so that's fine. But sometimes there are things that would need to run for a long time, like you're processing, I don't know, you're computing some protein folding stuff in a VM. And perhaps you're going to end, or you would like to orchestrate services that are using server-full kind of workloads, so stuff that usually runs in a VM, for example. So in that case, you can also, from a workflow execution, create a new VM, start the VM does its thing, and once it's finished, you're going to get back and stop the VM. So you don't have to have a VM that runs and is super expensive with GPUs and whatnot, but you're going to start it and end it. So you can bring back some serverful aspects into a serverless aspects. Well, I'm out of time. Long-running batch jobs with service orchestration. We also have a cloud run jobs service that exists. So you can run things into containers, and once the containers completes its work, it's going to return. So you can also use that. Very, very quickly, because I'm over the 50 minutes already. Use a GitOps approach, at least in the sense that use different environments. So you've got a staging environment, and you want to push on a commit. The workflow is updated, then you're going to deploy the workflow, etc. So, well, usual GitOps kind of stuff. And for the environment handling, actually, so either you have different environments, different workflows, sorry, per environment, or one single workflow, but you can use runtime arguments to say, OK, I want to run this particular workflow within that environment. Or another approach that we used in some of our samples, which was to just replace the URLs with staging versus or test staging, etc., or prod services URLs. So there are different approaches, different pros and cons, or you can use things like Terraform to do that kind of stuff. So if you really want to have a closer look, I didn't have enough time for those examples. If you want to have a closer look at this, please be sure to. So I'll share the slides on Twitter, and you'll have the links. But it's usually all those demos are on Google Cloud Platform, on GitHub/workflows demos if you want to dive deeper. Thank you very much.